Hi, we are from group
3.
So today we will present about protection for building steel connection,
Cementitious spray coating.
Jacket thriller, the show ain't nothing Miller. Man, I'm a lady killer. If I want her, I'm a stealer. I promise I can make her fly away like caterpillars. So if you don't know.
For this session, which is about the introduction, I will explain to you about what is cementitious spray coating. Cementitious spray coating is a passive fire protection system that is commonly applied to the structural steel connections and steelworks in buildings. It is applied by spraying a cement-based material directly onto the steel surface. The main purpose of this coating is to protect the steel from high temperature during a fire. When steel is exposed to excessive heat, it can lose its strength and affect the stability of the structure. Therefore, the cementitious coating acts as an insulation layer that slows down heat transfer and helps the steel maintain its load-bearing capacity for a longer period. One thing to notice is steel does not burn, but it can become weak and when exposed to very high temperature during a fire. When this happens, the steel may bend or deform, which can affect the stability of the building. The purpose of fire protection is not to stop the steel from burning, but to slow down the increase in temperature. This helps the steel stay strong for a longer time and keep the structure stable during fire. Cementitious spray coating is commonly used in commercial and industrial buildings because it can be easily applied to different steel connections and members.
Continue with that, we are going to discuss about purpose and function of construction or installation of protection for building steel connections, cementitious spray coating. So first is to provide fire resistance. The primary purpose of cementitious spray coating is to protect steel from rapid temperature increases during a fire. The coating acts as an insulating barrier that slows heat transfer from the fire to the steel. This helps the steel maintain its strength for a specified fire resistant period. Second is to maintain structural stability during fire. Steel loses significant strength when exposed to high temperatures around 500 to 600 degrees Celsius. Cementitious coating delay the heating process, allowing beam, column, and steel connections to continue carrying loads and preventing premature structural collapse. The third one is to protect steel connections. Steel connections such as bolts, wheels, and connection plates are critical component of a steel structure. Failure of this connection can lead to partial or total structural collapse. Cementitious spray coating protects this connection by reducing heat exposure and preserving their load carrying capacity during a fire. The fourth one is to increase evacuation and firefighting time. By slowing the rate at which structural steel heats up and weakens, cementitious fireproofing provides occupants with more time to evacuate safely and give firefighters additional time to control the fire before structural failure occurs. And lastly, to comply with building fire safety regulations. Many building codes and fire safety standards require structural steel members and connection to achieve a specific fire-resistant rating. Cementitious spray coating help building meets this regulatory requirement and fire performance standard.
First, step 1. Installation of steel structure. Before installation begins, all steel members and steel connections are expected to ensure they are properly erected according to the approved structural drawings. The inspection also checks whether the steel surface are free from oil, grease, dust, rust, loose paint, welding slag, and other contaminants that could reduce the adhesions of the cementitious spray coating. Any damaged or defective steel components must be repaired before the fireproofing works begins. Next, step 2, surface preparation. The steel surface is cleaned thoroughly using wire brushing, grinding, or abrasive blasting where necessary. Surface preparation is important because clean steel provides better bonding between the fireproofing material and the steel substrates. It's specified by the manufacturer, and anti-corrosion primer compatible with cementitious fireproofing is applied and allowed to dry completely before spraying. From the picture, we can see that the worker cleaning steel beam using wire brush and a sandblasting of steel members. Step 3. Mixing the cementitious material. The cementitious fireproofing material is supplied as a dry powder. It is made with clean water using a mechanical mixer according to the manufacturer recommended water to material ratio. The mixture must be blended until a uniform, lump-free consistency is achieved. Proper mixing ensures that the material can be sprayed evenly and provide the required fire-resistant performance. In the picture, we can see that mechanical mixer preparing cementitious material, and there's also a batch of cementitious spray material. Step 4. Spray application. The mixed cementitious material is pumped through a spray machine and applied directly onto the steel connection and structural member using compressed air. The nozzle is positioned at an appropriate distance to ensure uniform coverage. Several spray passes may be required to achieve the specific thickness. Particular attention is given to beam column joints, welder connection, bolts, and steel plates to ensure complete protection. In the picture, we can see the worker spraying cementitious coating into the steel beams, and it also spray around the beam column connection. Step 5. Thickness inspection. After spraying, the thickness of the coating is measured using a wet filler gauge or depth gauge. The measure thickness must comply with the fire resistance rating specified in the project drawings, which may range from 1 hour to 4 hours of fire protection depending on the building requirement. Areas that do not meet the required thickness are resprayed until they satisfy the specification. In the picture, we can see that the inspector is measuring coating thickness using the thickness gauge on the coated steel. Step 6. Drying and curing. The applied cementitious coating is left to dry and cure under suitable environmental conditions. During this period, the coating should be protected from heavy rain, excessive moisture, physical impact, and vibration. Proper curing allows the coating to develop sufficient strength and adhesion to the steel surface. Lastly, step 7. Final quality inspection. The final inspection is carried out to ensure that all steel members and steel connections are fully protected. The inspector checks coating thickness, surface uniformity, adhesion, and any sign of crack or damage. Any defects found during inspection are repaired before the building proceeds to the next stage of construction. Once approved, the fireproofing work is considered complete and complies with the project's fire safety requirements. In the picture, we can see the engineer inspecting completed fireproofing work and a finished fireproof steel structure.
Next, I will explain the advantages and disadvantages of cementitious spray coating. Let's begin with the advantages. The first advantage is excellent fire resistance. Cementitious spray coating provides effective thermal insulation, allowing steel structure to maintain their strength for 1 to 4 hours during a fire, depending on the coating thickness. The second advantage is that it is cost-effective. Compared to other fire protection methods such as intumescent paint, cementitious spray coating is more economical because both the material and installation costs are lower. Third, it offers high versatility. The spray can easily cover complex steel shapes, including beams, columns, bolts, and connection details, ensuring complete fire protection even in irregular areas. Lastly, it provides acoustic and thermal benefits. Besides improving fire resistance, the coating also helps reduce noise, provide additional thermal insulation, which enhance overall building performance and occupant comfort. Now, let's move on to the disadvantages. The first disadvantage is it is poor aesthetic appearance. The finished surface is rough and bulky, making it unsuitable for exposed steel structure where appearance is important. Secondly, it is prone to damage. The coating may crack, chip, or detach if subject to impact, vibration, or rough handling during construction or building use. The third disadvantage is limited moisture resistance. If exposed to water or high humidity without proper protection, the coating may lose durability and require additional protective finishes. Finally, application process can be messy. Spraying creates dust and overspray, so proper safety measures and cleaning are necessary during installation.
Now, we have come to the conclusion. Sum up, cementitious spray coating is an effective and reliable passive fire protection system for structural steel connections. Its main function is to slow down the transfer of the heat to the steels during a fire, helping the steel maintain its strength and stability for a longer period. The installation process is simple and allows the coating to cover different sizes and shapes of steel member and connections. In addition, cementitious spray coating is widely used because it is cost-effective, easy to apply, and provide the required fire resistance for many types of buildings. Overall, cementitious spray coating is a practical and economical fire protection solution that improves the fire safety, stability, and durability of steel structures. It continues to be one of the most commonly used fire protection methods in the construction industry. That's all from us.